Imagine a vast, self-sustaining habitat floating in the depths of space, where entire communities could live, work, and flourish in a garden park world tailored to their needs and desires. The Bernal Sphere is one of the earliest and most iconic visions of a space habitat, conceptualized by John Desmond Bernal in 1929. This bold idea presented a self-sustaining, rotating spherical structure 10 miles wide designed to house thousands of people in space. The sphere's rotation would create artificial gravity on its inner surface, enabling residents to live and work in an Earth-like environment. With provisions for agricultural zones, living quarters, and energy systems that harness solar power, the Bernal Sphere offered a comprehensive approach to human settlement beyond Earth, addressing fundamental needs such as food production, atmosphere control, and radiation protection. Bernal's concept inspired future space architects and science fiction creators by presenting the vision of a permanent, habitable outpost in space. It laid the groundwork for later, more complex designs like Gerard K. O'Neill's space habitats, and influenced the broader discussion on space colonization. The Bernal Sphere embodies the ambition of expanding human civilization to the stars, envisioning not just survival, but the possibility of thriving in the cosmos. Today, we'll be exploring the design, its pros and cons, and when or if we should build one. But we should probably start with one common misconception. The Bernal Sphere is not the first space station design, either in science or science fiction. Who holds that title is difficult to say, but Edward Everett Hale's 1869 short story in The Atlantic, The Brick Moon, qualifies as a very basic space station or manned satellite, while Hugo Gernsback, often called the father of science fiction, would give a brief but slightly more scientific exploration of an orbital platform in 1911. Hermann Oberth, one of the fathers of rocketry alongside Tchaikovsky and Goddard, would go on to discuss using them in his 1923 book, translated from German as The Rocket into Planetary Space, where he discussed the potential for human space travel and the practical use of space stations as stepping stones for interplanetary exploration. Indeed, he would discuss the basic wheel design that uses centrifugal force to simulate gravity that Wernher von Braun later expanded on and popularized as the von Braun space wheel, and he was also the first to suggest solar power for running the station's life support, and that such a station might serve as exactly that, a station for ships stopping by before heading into a wider voyage. We tend not to think of space stations as refueling points these days, since none of our current or past stations, over a dozen to date, has served in that role, but I thought it was a good point to note for today because while Bernal Sphere wasn't the first space station design, it was the first space habitat design that I'm aware of, and a space habitat might serve as a waypoint for travelers and trade, but is fundamentally designed meant for living and supporting a community. We tend to discuss O'Neill cylinders a bit more often on the show, but in fact the cylinder design was O'Neill's Island 3 design. Island 1 is simply an updated, detailed, and slightly smaller version of Bernal's original sphere, while Island 2 is a reimagining of it to be a bit bigger and more elongated than spherical, and that is the design you will probably most often see and tends to be called a Bernal Sphere, even if it's quite different than Bernal's original design. We'll be looking over all three today, Bernal's design in Island 1 and 2, as well as some other approaches to the concept. If that sounds like fun, grab a drink and a snack, hit the like button, and don't forget to subscribe to the channel for more discussions of space, science, and futurism. If you didn't already know, I'm the president of the National Space Society, which is actually international, but the name is left over from when the National Space Institute, founded by von Braun, and the L5 Society, inspired by O'Neill's work, merged in the mid-1980s. The NSS is not solely focused on paving the way for giant space habitats, but it tends to be one of our central long-term goals, and hosting design competitions for these space habitats, from students to experts, is one of the ways we do that. So as you might imagine, I'm familiar with a lot of variations on the core designs for space habitats, and of course it was a keen interest of mine even before I joined the NSS, and indeed was the motivation and topic for our very first episode of the show, the Megastructure Summary, which briefly detailed a large number of space habitats and other structures. But this is also part of the reason why detailing the original Bernal Sphere is a bit tricky. Tons of engineers have looked at the idea down the years, but Bernal himself didn't dip into many details in his discussion of it. It appears in his 1920 essay, The War, the Flesh, and the Devil, which is unrelated to the 1959 post-apocalyptic film of the same name, drawing off the Latin version Mundus Caro et Diabolus, which St. Thomas Aquinas singled out as the three sources of temptation and implacable enemies of the soul. You might be wondering what it has to do with space habitats, and the answer is not much. The text discusses everything from the space habitat to wireless power, cyborgs, transhumanism, and hive minds, with a large dose of his personal politics. But the subsection on the Bernal Sphere, which is the truly memorable part in my opinion, feels almost like it hijacks the work as it takes up most of the second section, the world, of the six-section work. He essentially shifts from talking about the progress and efficiency of food production by modern science to how the world's limited land area will always be a constraining factor on growth, and the nascent notion of a Dyson sphere pops up here as he notes how the sun gives off 2 billion times more sunlight than the Earth receives. So he is overtly discussing this as a space habitat made for the purpose of letting more people exist and how we should build many of them, that it has citizens, not just employees. This to me is the more revolutionary idea than the station details itself, as it acknowledges that even all the other planets in the solar system, if made habitable, don't add that much more living area for humanity. While the power and resources available to those building space habitats is several orders of magnitude higher, generally 1 million to 1 billion times more. So the Bernal Sphere isn't just a waypoint to explore new worlds, a novel place to visit, but rather where most people might live. One day people may live in big space habitats around alien planets, but have you ever wondered what the universe might look like from the perspective of big aliens? Our Nebula exclusive episode, The Big Alien Theory, dives into the fascinating question of whether humans are an anomaly in the cosmos due to our relatively small size, and if big aliens might need to be too few and far between to generate civilizations on their homeworlds. Could this be the key to solving the Fermi paradox? Join us on Nebula to explore the statistical and scientific reasoning behind this intriguing concept. Nebula is the largest creator-owned streaming platform, where every SFIA episode airs early and ad-free. Nebula also features tons of exclusive content from myself and many other creators, like Real Engineering, Real Science, The Science Asylum, Simon Clark, and more. Sign up at go.nebula.tv/IsaacArthur using the code IsaacArthur to get 40% off an annual plan, making it $3 a month. Nebula also offers lifetime memberships and gift options, so you can share awesome content like Big Alien Theory with friends and family. Just go to go.nebula.tv/IsaacArthur. And now, let's return to Big Bernal Space Habitats. As to the specifics, the reality is his design was not particularly good, especially as we learned more about space. For instance, he suggests detecting dangerously large meteorites by the effect of their gravitational fields, or vaporizing them with jets of gas or electron beams. Ironically, the part of it long considered the weakest, in the literal sense, is that the outside be completely transparent to let sunlight in. He basically envisioned a crystal ball or snow globe. This is a bit more plausible with modern science, where manufacturing the outside of something ultra strong and transparent, like diamond, is on the table. He is thinking of this outer layer as the membrane of a cell through which power enters to run an outer mechanical layer. While it's a 10-mile wide sphere, Bernal assumed only the inner 8 miles, or 13 kilometers, with a spherical living area of 201 square miles, 521 square kilometers, 5,200 hectares, or 129,000 acres, for whichever best lets you visualize the living space. Folks already familiar with space habitat designs are probably wondering why he wants light coming in through the floor, but the structure isn't rotating for spin gravity. He is actually assuming these habitats are awesome because they are free of bad weather and gravity, and thus also made houses mostly superfluous. And beyond granting the possible need for some smaller soundproof cells, He was assuming we'd all float around happily and get used to the low gravity. We didn't actually know zero gravity was unhealthy to the 1960s, when people spent a fair amount of time in it, and that's pretty much when we see the rotating designs come in. I think for space station designs, even when folks wondered about a lack of gravity being unpleasant, they weren't assuming serious and short-term health downsides yet. Once that became the case, we see von Braun's space wheel as the space station version, and shortly after we see folks like O'Neill point out we could just spin Bernal Sphere around. If you're curious, one rotation every 3 minutes will give it normal gravity, at the equator anyway. But it's important to note that the original Bernal Sphere wasn't a spin gravity habitat, which it is now one of the 4 most famous examples of, others being the cylinder, rings, or torus hoop. Rather, this initial Bernal Sphere is what we often call a bubble hab or free-floating hab. Once we talk about turning it into a spin gravity station, we start some re-engineering. First, there's no reason to have the floor under people be where the sun comes in, and where it would be turning on and off every 3 minutes unless your pole was pointed at the sun, instead leaving one half eternally lit and the other always dark. And it just introduces structural weakness, which is unwelcome in a station that now has significant centrifugal force on that structure. Those poles are also very low gravity too. There's no spin at the pole itself, so as you leave the equator, gravity drops. That's fine in some ways, as low gravity can be handy. You might like sleeping at 1G but working at half gravity, and probably a lot of organisms would adapt well to those spots. You might get some awesome trees in quarter gravity, for instance. You also need some place for the sunlight to come in, so it's often imagined that one pole of the sphere is a window facing the sun, and either you close that at night times or spin the habitat on its other axis so that it rotates not just every 3 minutes for gravity, but also the other direction once every 24 hours for daylight. It is also structurally more solid than a simple cylinder, as those big cylinder caps are not exactly their preferred engineering. This is why we get the Island 2 design, which replaces the sphere with some more elongated structure akin to an egg. There's a small percentage of low-gravity areas in this approach compared to a sphere, though the ring and cylinder approaches have uniform gravity from uniform radius of rotation. Note that both Island 1 and 2 are a lot smaller than Bernal Sphere. Island 2 is only about a mile wide, not 10, and Island 1 is 0.31 miles or 500 meters in diameter, and would need to rotate about twice per minute for spin gravity, which would get to be nauseating unless you were pointed right at the sun and it stayed centered. It would drown out the rotating stars, much as our sun does during daytime, but like the Stanford torus design, the later Bernal Sphere concepts tend to incorporate mirrors to bring sunlight in. We generally do not assume Bernal Spheres are actually spheres anymore, but then an O'Neill cylinder is rarely designed with flat caps either. Both tend to assume you use a hemisphere as a cap, or maybe a somewhat flattened one. The line between an ovoid-shaped habitat and a hemispherically capped cylinder can get a bit arbitrary, though having a slight change in radius along the axis can help supplement weather and terrain by giving you downhill and uphill and variations in air pressure. A full and proper sphere obviously does this much more, and only about 3/4 of the surface area of a spinning sphere is experiencing more than half the gravity the equator does, and only 2/3 experience even 3/4 gravity or more. I think in a real spherical habitat we would probably push the gravity up to 20 or 30% higher than Earth's, just to ensure most of the territory was at Earth gravity, or close to it. You probably end up with a river or lake or sea along the equator too. Higher gravity doesn't affect buoyancy, and unless you are intentionally building deep seas beyond the depth light normally penetrates, the slightly faster rise in pressure underwater won't matter much. All this change to pressure and gravity ought to give you a decent weather cycle, which might be preferable to the more tame one a simple ring or cylinder might produce. Although as I am recording this after plowing my driveway free from 4 feet of snow, I would argue that we only want so much weather variation. But we have another issue too. Spin gravity only points away from the axis of rotation, so if you're standing on a sphere, you're thinking you point head first toward the middle with the ground flat under you, but instead the ground is curved spherically while the gravity points to the axis, only at the equator is it properly aligned with the ground. That means out at a 45-degree angle, not only is the gravity down to 71%, it is facing diagonally from the ground. This also means that not just air and water, but also dirt and mud will slowly drip down from the polar regions to the equator. This is not fatal though. You could create many tiered levels, themselves flat around the axis of rotation, so gravity points the right way. We might assume each tier represented a 1% decrease in gravity, starting from that equatorial river belt, which in this case would be about 0.6 miles or 1 kilometer wide. Your tiers are all vertically the same height higher than the last, as gravity from spin is proportional to radius, so on a 10-mile diameter or 5-mile radius station with 100 tiers on each hemisphere, it is rising 264 feet or 80 meters a level. These ring-shaped tiers or bands are not equally wide though, and subsequent tiers are decreasing not just in gravity but land area. So when gravity is just 1% lower, you got about 9.1 square miles or 24 square kilometers, while at half gravity the tier is down to about 1.4 square miles or 3.7 square kilometers, and the spot with less than 1% gravity is just 0.16 square miles or 0.41 square kilometers. I tend to assume neighborhoods would not simply be these bands, though addresses might be, and I would bet the bands would be more numerous and more likely the equivalent to a normal flight of stairs. Under all this is dirt, but even if the weather helps you, you probably have a lot of small lakes and ponds on higher tiers and active water pumping going on below ground to move from the central ring sea to the polar mountains. You might have some awesome waterfalls here too, either one that went down hundreds of small waterfalls with each tier, or one that did many tiers at once. And these tiers do not have to be flat walls. We can add curvature, where a tier band doesn't run the same distance from the equator its whole length, or to the vertical too. You really won't notice the floor being 1 degree of gravity off. That's typically what most decks and balconies have to keep rainwater from pooling up, or to let melting snow drip off, so you might have a spot where you ran down long smooth slopes or where you had even more and shorter tiers, like you want fish like salmon to be able to move upstream. You also don't need to have water run directly along the axis. Rivers meander naturally anyway, so you can have more modest slopes for your rivers in the structure by having them move on winds and sideways. Normally land we live on has slopes from the center of the island and the continents to sea level. I live in northeast Ohio by Lake Erie, currently experiencing lake effect snow, at an elevation of 275 meters or 900 feet, and in the hundreds of miles that water flows to from when it rolls off my own balcony, down to the Ashtabula River, down to the lake, and eventually out to the Atlantic Ocean, the slope is about 2% of a single degree. River speeds vary by a number of factors, but slope is one of them. A moderate river can have a slope of 1%, and fast ones much more. I am obviously a big fan of Gerard K. O'Neill and his highly influential book The High Frontier, where these structures get discussed, and he just as obviously had time and space constraints on how many examples he wanted to give, but I always wished he had included a few more in-between cases, including a full-size Bernal Sphere. Again, a 10-mile wide Bernal Sphere has 314 square miles of land. The 8-mile living area version would be 201, and has only 64% the land area of the 10-mile version, but then Island 2, depending on the version, has just a tenth the radius and 1% the area, or a fifth the radius and 4% the area, and Island 1 is just 0.39% the area. A 10-mile sphere is hardly big by our channel size. We consider structures even into the light-year scale, but it's legitimate to ask how often we would really need to build even that big. You are probably much more population dense in one of these habitats than a random chunk of modern Earth, which is only 16 people per square kilometer or 41 people per square mile. That jumps to 54 and 139 if we cut out the oceans and only do land. If we use that figure, we would expect 43,646 people per 10-mile sphere. We could probably do a lot more. Ohio is hardly known for being densely packed and is nearly twice that density. But then we also need to either put a fake sun in the center of this globe or leave a decent window in one of the poles. The window doesn't have to be full size, incidentally. We can use mirrors to concentrate light in through that window and widen that incident angle, or move it closer to the sun. Indeed, you could flip the opening around backwards, facing away from the sun, and have a giant parabolic mirror behind the sphere bouncing light back into it, gathered from a much larger area, so as to allow such a sphere to be comfortable even when as far from the sun as Pluto is. Alternatively, a smaller pinhole shape, able to let sunlight in and diffuse around, with the rest of the sphere covered in mirrors, could also let a habitat be even closer than Mercury without getting hot. And again, we would expect population density to be higher, partially because we also tend to assume you do most of your agriculture in smaller ancillary stations tethered to the bigger habitat where the gravity might be lower, requiring less structural strength. You also don't need the same levels of radiation shielding and meteor protection that an urban or suburban habitat where people live and children play needs to have. You can cover the outside of a station in solar panels if you want, or mirrors, or just raw shielding, and again you might use mirrors to bounce in the amount of sunlight you want and without the more dangerous wavelengths you don't want. Now, would you build one? Yes, but not often. I think that more often folks would go for the stretched ovoid or slightly slanted neocylinder with hemispherical caps. One reason folks often think we'd go spherical is because asteroids are spherical and we could just hollow one out and spin it. But asteroids aren't particularly spherical, especially down at this size range, and you can't spin an asteroid around fast like that. Your typical asteroid 10 miles wide is not even 1% of Earth gravity, where if you dropped a rock from your hand to the floor it would take about a minute to land. Spin that up to 1g and that surface gravity changes to 99.99% of normal Earth gravity, but upwards, not downwards, shredding that rock apart. You'd have to build a whole mesh around it of great tensile strength, and there's no special reason to make that shell a sphere of that radius anyway. It makes just as much sense to drill a cylinder into that asteroid and put a habitat there. Sphere or cylinder, it's rotating inside that asteroid. The asteroid is not rotating, at least not beyond its normal spin, which tends to be an inconvenient value of a couple hours for most asteroids, not a 24-hour day. And you don't just hollow out a 10-mile wide asteroid to get a 10-mile Bernal Sphere. That's the whole point of why rotating habitats beat planets. They are hollow, so use way less mass. If we imagined we wanted 30 meters or 100 feet of ground under us, made of water, rock, dirt, and some strong shell material like steel or graphene, and you end up with a sphere about 170 miles or 270 kilometers wide, not 10, and with an area not of 314 square miles like before, but 87,000 square miles, 224,000 square kilometers, or 55 million acres. The latter, our original Bernal Sphere, is the size of a modest county. This is more like the size of Wyoming or Oregon. Whereas our other Bernal Sphere, 10 miles wide, only needs an asteroid maybe 2 miles wide to build it. And that's a thick shell too. You'll get less radiation coming through that than on Earth, and by a wide margin. 100 feet of armor and rock is pretty attack-proof too. If you want to take something like this out, you need a direct nuclear bomb blast and high yield too, not something low kiloton scale. As we discussed in some of our space warfare episodes, you're never going to get a device as complex as a nuclear bomb that close to anything with a serious point defense system either. Those defenses just can't miss an object that big. As usual, these things are way too expensive for us to build right now by launching material from Earth, so the notion is indeed to source them from asteroids, and even built inside them. Just don't think of us hollowing out a natural asteroid for a single sphere. And as I've mentioned, while Bernal talked about a 10-mile wide sphere that had no gravity and was a bit like a blend of a hollow glass ball and a photosynthetic cell, the usual versions are the smaller ones O'Neill discussed, though as I've also mentioned there are tons of versions. The Kaplana 1 station we often show is a close cousin to the Bernal Sphere. Babylon 5 from the TV show of that name is an example of one, though you'll hear it called a cylinder too, and visually it resembles both. In this regard, we would probably very rarely see a pure cylinder or sphere. What's more, you probably won't often see a singular version out there. If you just need a small habitat, you go for a ring or a torus, as we discussed in the Stanford torus episode before. It gets you the necessary level of gravity at a low spin rate without too much material. Your spheres and cylinders are way more efficient in terms of surface area and raw materials per unit of living area though, so you build them when you're building larger communities, and you are generally going to find it more useful to build conglomerations of smaller habitats along with a large mix of different specialized structures, agricultural stations, industrial facilities, low-grav docking ports and shipyards, solar collectors, and so on. And here you might have a sphere encasing all that, to help with space junk and leakage and provide initial defense against radiation, meteor, and attack. Just a huge thin shell around everything else that they float around in a vacuum still, but a less radioactive one, and through which no high-speed junk was moving either. And much as Bernal's original sphere wasn't quite what we picture it as now, with zero gravity inside, this hollow and pressurized sphere with smaller facilities inside it, some pressurized and under spin gravity, might be how spheres end up as home for humanity in the future. Either way, nearly a century after Bernal first suggested the idea, it's running strong, with many new ideas and modifications suggested. And I think it very likely it won't be more than another century before we start seeing them or their cousins getting built.